Hello, everyone, and a very big welcome to our celebration of International Women in Engineering Day here in Lincolnshire. I'm Professor Libby John. I'm head of the College of Science at the University of Lincoln, and I'm very excited today to be showcasing some of the work of remarkable women engineers at different career stages from across Lincolnshire. So it's a very exciting event for us today. Now, engineers, I'm not an engineer, but I'm in awe of what engineers have done for us and are doing for us on this planet. Such important people. Engineers solve problems and make the world a better place. And there are roles for engineers in so many areas, whether it's designing robots to harvest crops or conduct delicate surgery, designing solutions for climate change and flood defense, making manufacturing processes more efficient, ensuring our vehicles are energy efficient and safe, or keeping things working. You'll hear much more in the presentations to follow about the different paths that women engineers are taking through their careers, and some of the fabulous and exciting work they're doing. Now, if you're inspired by anything you hear today and you're not an engineer and you think this could be a career path for you, even if it's just an inkling of a thought, please do pursue that. There are lots and lots of different ways of getting educated, learning more about engineering in Lincolnshire. I'm very pleased that the University of Lincoln is part of the Lincolnshire Institute of Technology, which offers engineering courses across Lincolnshire, in every corner of Lincolnshire. And of course, at the university here, we also offer engineering degrees. And there are a variety of routes to take through your engineering career, different entry levels and different ways of becoming an engineer, including through the apprenticeship route, which allows you to work while you learn. So please do get in touch with us if you want to learn more, or look at the Lincolnshire Institute of Technology website, where you'll find links there to all the colleges offering engineering programs across Lincolnshire. I hope you enjoy the talks that are going to follow. We will have a live question and answer session where all our speakers will be present at the end. So please do save up your questions for them, or pop them in the chat as we go along. You can put comments into the chat and we'll see them. We'll probably address them at the end, however, when we get there, when we can have a conversation about the roles of women engineers and the career paths they've taken to get to where they are today. So enough from me. I'd like to start by introducing our first speaker. I'm really pleased that we can start by hearing from Professor Minnie Sarge. Minnie is a global chair in robotic engineering at the University of Lincoln. She joined the university in September 2019. There she is. Hi, Minnie. And she is originally from India, where she did all her studies. Hi. Minnie is a role model for aspiring space engineers, particularly female engineers. And this is because Minnie is an internationally renowned academic, a space engineer in a male-dominated profession, and a proud mum of two daughters, aged 20 and 15, absolutely showing that it's possible to do it all, be a wonderful mum, and have a remarkable career. So I'm going to hand over to Minnie there to talk about space engineering, a rewarding career.
Thank you for the kind introduction, Libby. Good afternoon, all of you. I'm really delighted to be here today to talk about my journey towards space and how I became an engineer. So I really hope you'll find this talk insightful, and hopefully we will be able to encourage more and more females to become engineers, not just engineers, but space engineers. Well, myself, I'm a trained space engineer specializing in robotics and control. I'll tell you what all these terminologies mean in a little later. But let me start with engineering as a career. So why did I pick engineering, or what we engineers do? So at the age of being in school, say high school level, you might be wondering what are the different career paths for you. And obviously, engineering is one of the most reputed professions. And engineering is not just about fixing things, because we engineers, we are specialized or we are qualified to do special jobs that are creative, that require intelligence, a lot of intelligence, and we are innovative people. So when it comes to engineering education, there are different streams of engineering. And myself, I did my first degree in electrical engineering. There are people who enjoy the electronic side more than electrical, or the electricity or the power related education. There are engineers who are specializing in the mechanics or mechanical systems, who are really good at designing engines for aircraft, marine vessels. There are a lot of automotive devices that requires design aspects. Obviously, civil engineering is an area that specializes in construction, and it is also related to architectural engineering. And there are other streams such as chemical engineering, aerospace, computer science, and so forth. We engineers, we specialize in these areas, and if you get a chance to go for higher studies, you can then become a more special, or a very or a highly qualified engineer specializing in other substreams. And myself, I decided to specialize or do my master's degree in systems and control engineering, which actually opened up several new channels or opportunities for me. So that was a time when I started exploring more about robotics, what I can do as a control engineer. So with my first degree in electrical and electronic engineering, I then specialized in control engineering, and I started looking at how I can apply my skill sets in understanding of systems or control, different real life platforms such as robots, aircraft, launch vehicles, satellites, and so forth. So that was a very interesting journey for me, because if I recall the days when I was in my primary school, I was really keen to become a medical doctor because I loved biology. But as I grew up and moved to senior school, my interest started shifting. Or I started enjoying maths much more than biology. Although I was good at all these subjects, I found maths much more easy for me to handle. And obviously, engineering was one of the career, or the professions I was keen to do. And you might wonder why, why or how I ended up becoming a space engineer. And there is another very interesting story behind that. So I was lucky to be part of the Indian Space Research Organization's family. Or in other words, my dad, he worked for the Indian Space Research Organization, and he used to build rockets for ISRO. And I was taught or educated in the Vikram Sarabhai Space Center School, which is a school dedicated for the employees of ISRO. And during my time at my school, it was a dream for me to work like my dad for the Indian Space Research Organization. And as I started doing my higher education, I was very determined that I will become a space engineer, because that was the only profession I was considering at that age. I'm glad I did that, because although there wasn't an opportunity for me to work for ISRO, I found other exciting opportunities overseas or abroad. And I, after completing my highest educational qualification, which is a doctorate level degree in control engineering, I was able to do exciting research at internationally leading organizations in Germany and several organizations in the UK. So basically, I had a long journey all the way from India, taking a stopover in Germany, moving to London, working with the King's College London, and then joining the Surrey Space Centre, where I dedicated more than 15 years of my career working with the Surrey Space Centre, where I started the research group specializing in space robotics and control. So that's a interesting journey. I always recall when I look at what I do now and what my career aspirations were when I was a student. I'm really glad to say that today I'm a very well recognized or internationally known academic specializing in robotics and space engineering. Now let's see what I do on a day-to-day basis as part of my job. Well, because I'm part of the university environment, I do several things, but my main focus is in research. In the previous jobs, I have been also involved in teaching undergraduate and postgraduate degree students. I have taught several cohorts of students over the last 15 to 18 years. And at the University of Lincoln, I also take up several other exciting leadership roles, which I'll come to you in a minute. Now, looking at the research I do, as a space engineer, I continue to work on space missions. When I say space missions, the missions I'm interested is very much on robotic applications of space. Or in other words, how we can design robots that can do things which are difficult for humans to do in a very extreme or dangerous environment. So I work on space robotics. At the same time, I keep myself open to other opportunities because it's important that we engineers do not limit ourselves to one specific area or application. Therefore, the innovative technologies that we develop, we should be able to apply that for the benefit of the mankind in other sectors as well. And this is the reason you see all these other photographs, because these are the other domains I work on, because I'm very active in cross-sector technology transfer applications to medical domain, agricultural applications, nuclear applications. I also have some new initiatives in the area of aerospace or engine inspection and maintenance. And we are also exploring some new opportunities towards applying our autonomous robots in underground mining. So there's a big spectrum of opportunities or areas where we engineers can dive into. Now, let me just give you a glimpse of each of these without going into the details. So let me start with space robotics. So here, within the framework of space engineering and robotic for space missions, my main areas of focus are one on planetary robotics. Here, my interest is in designing micro, low-cost planetary rovers. As you can see in this video, we are working, or we are developing a small micro rover which can work in tandem with a primary rover. The big rover you see here is actually the breadboard constructed by Airbus Defence and Space for the European Space Agency's ExoMars mission. So we are working with several industries and other research organizations all across Europe, and we are also working with other international space agencies in developing concepts or mission concepts that we can realize in future exploration missions to Mars, Moon, and even asteroids. And whilst we work on extraterrestrial applications, I also work with several industries on other orbital applications where we are looking at how we can clean up the space, especially removing the space debris. And we are working towards a few missions with support from the UK Space Agency and space industries in the UK. Now, it's important to tell how we can also extend these technologies to other domains. So, for example, won't it be cool to help surgeons undertaking operations with the help of robots. So what I did was, when I started working on robots for space applications, I was also equally inspired to see how best we can apply these technologies for medical domain. And I started working with my clinical partners in terms of assessing how we can design soft, flexible robots which are very useful for minimally invasive robotic surgery. So rather than opening up our human body, which creates, bigger wounds, excessive bleeding, longer recovery time, we are developing very miniaturized, flexible robots that can really help or improve the outcomes of surgery through minimal interventions. So this is one area I'm collaborating with various clinical partners alongside other leading medical robotics research centers, both in the UK and Europe. Now, you have seen the shift from space robotics to medical robotics. Since I joined University of Lincoln, I found it very fascinating to see what is happening in the world of agricultural robots. And the University of Lincoln is one of the largest internationally recognized center specializing in agricultural robots. So since I joined Lincoln, I got some training on, what are the requirements of the farming communities of farmers, what type of vehicles they need to, say, undertake weeding operations or for harvesting applications. And now I'm working with a few companies who are specializing in building robots for the farming applications. I'm really glad to say that we are now building a pretty big robot, the one like a mini lorry, what you see behind us on this screenshot. And we are, interesting thing is, we are designing a completely electrically driven vehicle. So rather than using petrol or diesel, we are looking at the transformation to electrically driven robots. And this is one of the exciting projects that we are part of, or I'm part of in Lincoln, although we do have several other projects. Internationally, leading research is really important for all researchers like me. So as part of the University of Lincoln's research initiatives and international engagement, we academics, we are very active in reaching out to the external world to showcase the fascinating research that we do. And I'm very pleased to say that I have been part of several large-scale international initiatives, as you can see, which are organized by people or experts, engineers from different parts of the world. And having that kind of representation or presence is really important to showcase the cool research we do at University of Lincoln. So I'm really glad that as an academic, as a researcher, as an engineer, I have this opportunity to travel worldwide to showcase the fine research we do at University of Lincoln. Now, with that, I would like to say a very short statement about my teaching, although I haven't gone into the details yet. But as an academic and being part of university education, I had the wonderful opportunity to teach several cohorts of students, and it is an area I'm very passionate about, though at this stage I'm focusing more on research. So teaching and research goes hand in hand, and I'm really glad that I have taught several students over the last 15 years. Now, with that, I would like to also say a few words about the importance of public engagement, because when we do very clever things in an academic setting, it's really important to take this out to the external world, to tell the public, to tell people what we do. And it's a really valuable experience to engage with the public, to showcase again, what we do and how they benefit from the great research we do. So because as engineers, we continue to innovate, and we are enhancing or improving the quality of lives on Earth. So as a space engineer, although I focus one half of my time on developing future space missions, I also give equal emphasis on making sure these technologies can be applied for real world applications on Earth. And this is why I reach out to several schools, colleges, and also take part in public engagement events, which is important to really disseminate our work. So with that, I would like to conclude my talk, and I would like to say that as an engineer, I've been very lucky to be part of several exciting international programs, and I was part of several adventurous studies for space missions, and also I've been part of several other initiatives that are happening here on Earth, which is great. And in my experience being in the space sector for the last 25 years, I have had a very rewarding experience, and I very much encourage the next generation of engineers to consider space as a career option. But first of all, you need to decide which pathway you need to go, whether you want to become an engineer or not. And I can assure you that engineering is a very rewarding profession, and we want to see more and more females engineers working with us. And it is a very rewarding profession, not only for males, but also for females. So with that, I'm wrapping up my talk. Happy to take up any questions at the end. Thank you.
Well, thank you, Minnie. That was truly inspirational. Yeah, brilliant messages there. I love the message about how you can tailor an engineering career to be so flexible that you have applications that apply in many domains. And really liked that message about what engineers do is improve the quality of life on Earth. Because absolutely that is what you do, isn't it? It's so fundamental to the engineering profession. It's about making life better. So that was a really exciting talk. Thank you so much, Minnie. Yeah, I'm sure it has inspired many people and will inspire people, as of course we are recording all these talks, and they're going to be available for many months to come. So thank you so much, Minnie. Now, it's time to introduce our next speaker. So our next speaker is at a different stage in her career in engineering, just as interesting and exciting. So welcome to Shami Rahman, and thank you very much for being here. Shami is studying for her PhD at the University of Lincoln, and her PhD is being funded by Volvo Trucks, and she's focusing on improving safety systems in heavy goods vehicles. So Shami studied B.Eng in electronic engineering at Bangor University, and graduated with best graduating results, having achieved the highest marks of all students graduating that year. Congratulations, Shami. That's an amazing achievement. I'm sure you were very, very, very proud of that. And now she's working at Lincoln on safety systems in trucks, as we said. So over to Shami to talk to us about improving safety systems in long combination vehicles.
Thank you, Libby, for that introduction. So I want to start with the beginning of my engineering journey and what it was like when I first started. So I started my undergrad in 2015 in Bangor University. And during my time there, I completed 2 internships. One was on fabricating electronics chips, such as the ones you might find in your phone or in your laptop. And the other one was on detecting bees. So the idea was that you would mount an LED on a bee, and then the flapping of the wings of the bee would generate electricity to light up the LED. And then you can use image processing to kind of detect and track the LED. While I was at Bangor, I was also awarded some prizes, as Libby just mentioned, and I also got a scholarship while I was there. And then after I finished my undergrad, I took a year out, and then I started my PhD here at University of Lincoln in 2019. So, first impressions. When I first started at Bangor University, one of the first things I noticed was the lack of women in my class. So in my class, there were over 100 students, and only 6 of us was women. And then from first year to second year, and then from second year to third year, a lot of people dropped out. Some people failed. Some people decided engineering was too hard and transferred to other courses. But out of the 6 women who started in first year, all 6 of us graduated in 2018 together. So really, this thing that people say about women being not good at tech is just simply not true. And also, I think a lot of people think engineering requires physical strength. Again, this is not true, because as engineers, we mostly just design stuff. We barely ever actually have to physically build things. You might have to make some prototypes, but most of the time you'd probably just do simulations. And in terms of some reality, people do notice you when you're one of the few female engineers. And like, for example, when I was at Bangor, I was one of the six women in a sea of like over 100 men. And so obviously people would notice when you're one of the 6. But I think it's good when people notice you, because all my lecturers knew me. And that meant when I needed help, they would see me and they would remember that I attended on all the lectures, which would kind of mean that they're really happy to help me. And also when I needed reference lectures, it was like more personal, because they remembered me from the lectures. And it's true that a very small fraction of people might underestimate you as a female engineer. But in my experience, that hasn't happened very often, and nobody like important. Maybe my flatmate or somebody I was talking to in the shop might just seem very surprised, or might be disbelief in their eyes when they hear that I'm studying engineering. But I never ever felt like I was discriminated against for being a female engineer. And I obviously never felt like I wasn't given an opportunity just because I'm female. Okay, so what is it like doing an engineering degree? It's very hands-on. You have to spend a lot of times in lab. There's a lot of maths. Basically, every single module I had some sort of math in it. But don't worry if you're not very good at maths, because lecturers are very helpful. And even if you don't understand and you ask like 3-4 times, they would still try to explain it to you. It's also physics-based, so some of the theory you learn in your GCSE or A-level might come in handy. There's some programming involved in some of the engineering, but again, don't worry if you've never done any programming before. I myself never did any programming before I started my undergrad. There's a lot of lecture time with engineering. I know some of the courses require you to go into uni maybe 1 or 2 times a week. But with engineering, you might have to go in 4 times or even 5 times a week, basically every single day. And I think that's okay, because it's really worth the effort, because with an engineering degree, you have a bigger job market and you would probably get a higher salary as well. Okay, so now onto my PhD. So I'm currently researching long combination vehicles, and I'm trying to figure out how to make them safer. So what exactly is a long combination vehicle? These are vehicles shown down here. They're basically very long in terms of length, and they can also carry a bigger amount of load. And for comparison, there's also a tractor semi-trailer here. So you wouldn't see long combination vehicles like this in the UK, but they can be seen in maybe Canada or Sweden. There are a lot of advantages to having this really long vehicles, because they require less drivers, they're more fuel efficient, they reduce traffic congestion. But as you can imagine, with a vehicle of this size, there can be some issues. For example, when the driver is sitting over here, and because it's such a long vehicle, they're not sure, they're not aware of what's going on all the way over here. And that can sometimes result in some dangerous situations. And also, if you want to imagine one of these vehicles going about a roundabout, you'd realize they can be really difficult to maneuver. So some of the problems with long combination vehicles. So I got some pictures of the internet to show some accidents. So this is called a jackknifing. Here, this is just shown for a tractor semi-trailer, which is not a long combination vehicle, but it can happen to any heavy goods vehicles. So basically what happens in this situation is that the vehicle is going at a very high speed, and then the driver decides to steer, and then the vehicle kind of spins around, and the front part goes around and hits the back part of the vehicle. And in situations like this, most of the time, if the driver is still alive, they'd be very heavily injured. So it's really bad. And this is another situation where this is for a long combination vehicle made of a straight truck and a semi-trailer. So what happened here is that the articulation angle got too high, which is the angle between the front part and the rear part. And so it kind of got stuck. And then I think some other vehicle crashed into it. This also happens when the driver steers suddenly at high speed. Okay, so how am I trying to solve this problem? So I'm currently using this method called artificial flow guidance. It's basically an array of velocity vectors. So the controller needs to know the road configuration. And then based on the geometry of the road, it makes these velocity vectors, which kind of point the vehicle in the direction it needs to travel to end up at the desired position on the road, which here I assumed is the center of the road. And because these are vectors, they have both magnitude and direction. So using this, you can get both the steering angle and the speed that the vehicle should have to get to the desired position on the road. And here on the right side, I showed it being applied to a long combination vehicle. It's called a Nordic combination. It's made up of a straight truck, a dolly, and a semi-trailer. And I kind of showed an example of what these velocity vectors would look like at each of the axles on this vehicle. So the red arrows here show the actual velocity vector, which you can get by using a sensor to find the speed of the vehicle, and also the kind of direction, heading angle of the vehicle. And then by comparing this velocity vector you just generated by using artificial flow guidance to the actual velocity vector, you can kind of make them equal to each other. And that should make it maneuver better as well. Okay, so now I'm just going to show some video of how it works. So this was done in TruckMaker, which is like this commercial software where you can simulate trucks driving around. This is going to show a conventional vehicle, which means only the front axle on the truck here. So this axle A would be steering, and this doesn't have active steering. So this should show you what a conventional vehicle looks like when it's doing a lane change. And you'd notice the trailer swings around quite a lot. And as if you imagine there being vehicles on either side of this vehicle on the road, this trailer might swing into them, which can be really bad. So now I'll show you what it looks like when I apply FG to it. So here, the FG controller is applied to two axles down here. These are called the axles on the dolly, and also the front axle of the truck. And now you should see less swinging around of the trailer. And it also settles down a lot faster, which makes it a lot safer. And also removes the instability issues at high speeds. Okay, so that's really all I wanted to talk about today. Thank you for listening, and I hope it has been helpful.
Thank you, Shami. That was fascinating. It was a fabulous talk, so thank you very much. It was great to hear your reflections on being an undergraduate and one of only a number of female undergraduates, and the advantages of that. That was very interesting. And your research on truck safety is absolutely fascinating. I'd love to hear more about it sometime, and I hope our listeners found it as interesting as I did. I'm sure they did. So thank you. Our next speaker is Imogen Stevenson, and I am delighted to introduce her. She is the Regional Product Development Manager for Energy Performance Solutions at Siemens. Imogen obtained her MEng honours in mechanical engineering, control systems at the University of Lincoln. So she's a graduate of ours. And during that time, Imogen worked for 3 summers at Siemens as a summer intern. Oops. Excuse me, everybody. So that must have been a fabulous experience for you, Imogen, because after completing her degree, she joined the Graduate Engineering Trainee Scheme at Siemens. And now, as I've said, is Regional Product Development Manager in Energy Performance Solutions, a part of Siemens. So, Imogen, tell us a bit about your journey. And thank.
Yeah, thank you. Okay, so maybe I've taken a slightly different approach with the sort of 10 minutes or so that I have. I would like to maybe just run you through my career today, because I'm relatively early career still. So if I just take you back to my time before university briefly, it's worth just mentioning I did my GCSEs and my A-levels in maths and physics and chemistry, and had every intention of being a pharmacist, actually. But I really hated A-level chemistry, so sorry if there's any chemists on the call. So I had to change tact and decide what I wanted to do and what that meant, because clearly, you know, chemistry is critical to being a pharmacist. And I had a really amazing maths teacher at A-level, who was an ex-engineer. I couldn't really imagine this kind of small, petite maths teacher being an engineer, because in my mind, if I'm honest, that meant being a car mechanic. She kind of explained to me actually that there's some serious breadth to engineering, and it didn't mean that I'd be fixing cars for a living. So I decided that engineering would be a good route for me and started looking at universities. The Siemens connection and relationship that they have with the University of Lincoln was a massive draw for me, because it meant I could get a scholarship to study, and also, as you've mentioned, do placements in my summer holidays, which was really good to put into practice the things I was learning, to understand actually, you know, what did I want to do as a career after leaving uni while I was still studying. So again, when I finished university at Lincoln, I started a graduate scheme. I think it's fairly typical of kind of engineering graduate schemes in the UK. But what I'd highlight to you, and what's interesting about the Lincoln site, the Siemens Energy site, is that at one site, they do the design of gas turbines. And gas turbines, if you're not familiar, is basically a heavy aeroplane engine used for power generation. So they would design the core unit, they'd manufacture the unit on site, test them, and there was a competence centre for service globally. So they'd look after the fleet of units that were based all over the world, onshore and offshore. So to be able to see each step of that process was like brilliant, a fantastic experience. So after finishing my graduate scheme, I took my first position in service. I really like the service side of engineering because it's quite reactive, it's quite lively. You don't necessarily have time to engineer a long-term fix. You have to act now to support the customer and the site where the unit is. And after a few years of being in that role, I actually decided to take a slightly more commercial role. I don't think anyone's touched upon that yet, but there's a lot of breadth to kind of engineering, and it doesn't necessarily mean you would be a research and development engineer. So my role is Regional Product Development Manager. And what that means is it's a mix of technical and commercial. So it's thinking about what's the right solution for certain projects. And that's a balance of the right technical fit, but also at the right cost and time. So it's a really nice kind of mix of skills. So maybe if I just jump onto the next slide, I'll talk in a bit more detail about my role. So don't worry about the text on the screen. I think just to start, like what our team do is aim to support the UK with the transition to net zero carbon, and also look at saving businesses money and also resilience problems. So sometimes there are blackouts in part of the grid in the UK, and for some industrial processes, it's really important that that doesn't happen. So it's kind of security of supply. So how we do that is develop projects that aim to reduce the amount of energy that sites around the UK are using to produce kind of cleaner, more resilient energy, and also to procure the small amount of energy that might not be possible to kind of produce on site. We work with universities, with different industrial customers. So for instance, food and beverage, we're working with an ice cream manufacturer at the moment, and commercial. And again, that means kind of big, large office buildings like councils, for instance. So how I fit in with that kind of big problem that we're trying to solve is service. So I would support the team with opportunity development. So that initial conversation, working out what would be the right fit and how would we support the customer throughout the service lifetime. And also taking those projects into execution. So maybe to just talk about a practical example very briefly, we maybe would fit a large solar farm on a rooftop of an industrial customer. We might fit a gas engine that might run on biogas, and also install some LED lighting to reduce the energy that they're kind of consuming at the moment. And my job would be to work out how best to support them for the next 5 to 10 years. Okay, and then lastly, I just wanted to touch upon a few points. So why I chose engineering. I mentioned very briefly that I had a brilliant maths teacher, who I still talk about today, but really to just flag to you that I think the breadth and the size of the opportunity in engineering is huge. So there's so many different things you can do. And I hope you can see from the career path that I've taken so far that you have the opportunity to change and grow with the kind of the industry, being energy in my instance. I think a few people have already mentioned the salaries and the job security, which is also kind of an important part of the puzzle. But for me, it's just the expanse of opportunity that you have. In terms of challenges, I guess being really open and honest, I find, and I think it's probably quite typical of women in my profession, that confidence can sometimes be an issue. It can be really intimidating if you walk into a room of experts and they're all like older men and you don't maybe see any people that look like you. But just to turn that into a positive, I think what's exciting is it's just an opportunity for growth. So there's a lot of people that will know a lot more about you than you in certain topics, and you have an opportunity to learn from them and use it to your advantage. And I think the last thing I just wanted to mention that I don't think has come up yet is social responsibility. So I think it links to the first presentation, and finding solutions kind of on earth that people can use, you know, today and tomorrow. For me, working in a business where our core goal is to kind of transition the UK industry to carbon zero is really important. And I think that will be really important for your generation as well. So yeah, that ties up my talk. Thank you, Libby.
Thank you, Imogen. Yes, thank you so much for that different perspective on how you're helping to save the planet every day in your job. Isn't that an amazing thing to think that that's what you're contributing to the world? So yes, and how you got there was fascinating. And again, that same message that although it can be intimidating, feeling that there aren't necessarily people like you there, it's actually an advantage that you can make work for you and turn into a real positive. I also wanted to pick out that you, along with Shami, mentioned industrial placements, work in industry along the route of your education, which obviously was really important to both of you. So thank you very much, Imogen. Now, our next speaker is Dr. Isabel Campelos, who works at our National Centre for Food Manufacturing down in Holbeach in the south of Lincolnshire. And she's a researcher on Innovate UK projects with developing new food processing technologies. Isabel obtained her BSc in food engineering and a PhD in biotechnology, specialising in microbiology. She's got 20 years of professional experience split between industry and academia, and she works in an environment where that mix is there every single day, I think. So it's a really important place to be. And she's worked in technical and production departments as well as being a senior technical advisor at Leatherhead Food Research Limited. And she teaches food safety, food process technology, and engineering and food packaging, amongst many other subjects, to a wide variety of learners, many of whom are in work themselves, aren't they, Isabel? So thank you for being one of our speakers today, Isabel. Over to you.
Thank you, Libby. What an amazing session has been this so far. Yes, my background is in food engineering, which is a stream of engineering that combines the traditional engineering subjects, very heavily based on physics, but also looks at chemistry, biology, microbiology, and looks at the production of food products, the packaging, the processes. So in my case, I didn't have a calling. I didn't have a vocation, let's say. I was very split when I was choosing my degree, because I enjoyed all of these topics and I wasn't very keen on letting one go. So that brought me to food engineering that combined all of this. And it has been a nice run. I spent several years working with industry, feeling the difficulties of industry. And then I thought, well, I actually need to know more. I need to go to the next step. So I decided to take my doctorate. So it's never too late to engage with academia. And I end up doing this mix of research and lecturing and mentoring, which is something that I really enjoy. Like Sami mentioned, sometimes there is a teacher who inspires you. No, sorry, Imogen, the math teacher. There is a teacher who is inspiring. And I remember one of those as well. And I hope that I can be one such inspiring lecturer who can open up and make students believe that they can. And this is what is the reason of my presentation topic, is debunking this myth that engineering is difficult, that engineering is a hard thing to study, to develop yourself. I currently teach and I'm also program leader for what it's called a degree apprenticeship. That program is aimed at individuals who are working in a factory. In this case, because it's a degree in food engineering, it's a food and drink business. And at the same time, they are studying for their degree. But they have this wonderful mix of practical learning and then the theoretical learning, and how to bring these two together. So it's really, really an amazing opportunity for not only young students coming from A levels or to consider, because it's starting already with a nice salary, and it's learning from within, and it is possible. It's definitely possible. Oh, I apologize. Oops. So my name is Isabel. Thank you very much, Libby, for the introduction. I was carried away on my talk, and now I see it. So my background is in food engineering. As Imogen said, I wasn't, in her case, Imogen wanted to get away from chemistry. In my case, it wasn't getting away from one particular subject. I enjoyed everything. So food engineering is a mix of chemistry, biology, physics, maths, and for me, it suited me in a way that I didn't need to choose one particular area. Okay, so don't understand why it wasn't. So hopefully, yes. Okay. So engineering, as we have seen so far, is so interesting. We've seen our previous talkers, what amazing careers they've been having. And every day in engineering, it's a new challenge, it's a new problem. And the other myth that I'm quite happy to battle is that engineers are not creative. Very, very wrong. We have to think about the solutions to problems, and that is so exciting. Solving problems, getting the right solution is one of the most rewarding things in engineering, I feel. So engineering, the other myth is that engineering is hard. Well, probably this is it's a bit of truth, as Sami mentioned. It is hard work, but if you don't need to be a math genius to have a career in engineering, maths such as and the physics and engineering is just a question of effort. You have to put the effort in and time. If you commit yourself, it's like a game, right? If you are playing a game, a video game, you have to attempt to pass the level once, twice, 3 times, 4 times, and each time that you attempt to solve, pass that level, you will get a bit better. It is exactly the same with maths and physics. Everyone is capable of doing math and physics. And I have proved this to students once, twice, many times, fortunately. You can do it. It's like going to the gym. You really have to put the work in, but everyone can do it. So, no, engineering is not just for very smart people. It's for normal people, and everyone can get it. The other point is that engineering is not for women. Obviously, this is completely wrong. But the fact is that there is an image that there are few women in engineering, and it's more than an image, it's a fact. In the UK, around 12% of all engineers are women. If we compare that with the United States, that percentage goes to 20%. If we go to India, for instance, it goes up to 27, 30%. So we do have a lot of ground to cover in the UK. And that brings me to another topic that has already been mentioned. That is, it's a huge job market out there in engineering. There's such a need of engineers, male or female, doesn't matter. We need good, competent people to do the job. So really, as a career perspective, it is just great. And why engineering? So why do I praise engineering so much? Why am I so passionate about it? Well, I think it is fun. I see engineering as almost a game. There is a solution. It's like a puzzle. There is a solution. We just have to figure it out, how to find that solution. And we may have to look in several places and get to try several options, but we will find it. There's always a solution. An engineer always should come back with a solution, not a problem. We just need to use our imagination, and sometimes, many times, think outside of the box. We also develop the capacity to analyze the problems, to split them into units that are easy to tackle, to find the root cause of problems, of issues. And that also allows us to evaluate the solutions, the pros and cons that will inform a sound decision making. We learn to prioritize. We learn how to focus our efforts and to be efficient. And these are transferable skills that can really jump you into another job, such as, for instance, management or research or technical support, even politics, if you like. But those are really transferable skills that can jumpstart you anywhere. Oops, sorry. And I think one of the things that I really enjoy is that you see the results of your work, and you can always improve them. And there's so many possibilities, and that, as it was mentioned, if there are so many jobs around, and with a good pay level, even for starters. So just to finish, these are some images related to food engineering. So how do we do this sort of puffed interior? All these shapes and forms, a completely new biodegradable champagne bottle. We have heard about lab-grown meat that is going to probably also help save our planet. And here we have an example of 3D printed food. So the sky really is our limit. So thank you so much for listening. I'll be with you later to answer any questions. Thank you.
Thank you so much, Isabel. That was absolutely fabulous. You mentioned the importance of inspirational teachers, and I think you've just demonstrated that you're absolutely in that category yourself. That was a really great talk, so thank you. I loved also the way you focused on creativity being something that engineers have to draw on and using their imaginations to solve problems. I thought that was a fabulous talk, so thank you. Now I'm going to move on to our final speaker for today before we move to the question and answer session. And I'm really pleased to introduce Rupika Ravikana. She's a PhD student in agri-food robotics from our Centre for Doctoral Training called AgriForwards. Rupika is a first-year PhD student and she's based at the University of Lincoln. She previously graduated with distinction in a Bachelor of Engineering in Robotics and Automation and a Master of Science in Robotics and a Master of Science in Robotics and Autonomous Systems, so very well qualified. Her primary research interests include multi-robot systems and human-robot awareness with applications in agriculture, which I'm sure she'll tell us more about. So welcome, Rupika. Over to you.
Thank you very much for introducing me. So my talk would be a little different, I think, from the first three speakers, because I'm not talking about my research, before moving on, I would like to definitely acknowledge and appreciate that I'm invited here alongside absolutely fabulous women such as Minisaj and Isabel. I'm compared to them, I am in a much junior position. I'm just starting with my research career. So I think that makes me, a person who made a very recent decision to start studying robotics. So before I decided to take up robotics, I did have a lot of other options as well for my academics and for my work. But there were some perks I saw if I did end up studying robotics. And some perks I realized after, I went into studying robotics. So I'll be talking about the perks, which I realized were that you get while you study robotics. Okay, the first one is a bit silly, but it still remains my favorite. When you say you study robotics, it's like a one-word testament to your intelligence. The other person is always fascinated. They immediately think you're very smart, which might be the case most of the time. But you go on to say something stupid, people still think you're smart. So that is not something a non-engineering degree or a non-robotics degree would get you otherwise. Not meaning to say there aren't smart people in other fields. Absolutely, it's exactly the opposite of what I'm trying to say. But if you study robotics, people immediately think you're smart. So that is my favorite perk. Moving on, in a more serious note, I think when you take up robotics, you have the opportunity to create an impact in any field of interest. So when you look at medical robots, it is proven that using robots in medicine, especially in surgery, creates lesser pain, it's more precise, there is less rate of infection, and therefore a better recovery time. And Minisar spoke in detail about her career in space engineering, space robots. While it is absolutely path-breaking to have man on space, there is a certain limitation to the kind of experiments, the kind of research we can do while we depend on human beings to perform them outside of Earth. But space robots increase this horizon way and beyond. And moving on to production robots, these are robots you've probably seen, like they are now there in every other industry, be it car manufacturing, food manufacturing. So the image you see comprises of robotic manipulators. That is a very interesting subsection of robotics. So industrial robots not only increase efficiency of production, they also increase the operator ergonomics. They improve the quality of safety of laborers working there. They increase the output efficiency by taking up the more tedious and repetitive jobs and giving human beings a more interesting job to do. And then hospitality and care robots. So the world is not getting any younger. We are growing older as a society. Right now, as of 2020, there are 1 in 11 people who are aged over 65. By 2050, this number will be 1 in 6. So 1 in 6 of us will be above the age of 65. So there is an increasing demand for care robots to take care of elders or to do household work. This is where humanoids come into picture. So there is going to be a very high demand for hospitality and care robots in the next few decades or so. So agricultural robots, this is where this is my area of application. So I know a little bit more about the others I just mentioned. 1/3 of all the crops that are grown go unharvested and go to waste in the UK. This is in 2019 and 2020. 2021, in this year, the harvest season is about to begin, or it's already begun, and UK requires around 70,000 workers to perform harvesting. These people are called seasonal harvesters. And right now, we are in short of 40,000 people. So that definitely means a huge chunk of crops that are harvested, that are perfectly edible and usable, is going to go for waste. So robots in agriculture is not a luxury. It's more a necessity. It's more a pressing need. We absolutely need robots to carry out farm work, to carry out harvesting, weeding, monitoring of crops, and so, because there is a high level of demand for replacement of human labor in the area of agricultural robotics. But these are just few of the areas of application that I've mentioned here. There are a lot more. There's nano robots, which would again help with medical robotics. There are drones, which I've not mentioned about. They help with aerial imaging, and so there is underwater robots. And so taking up robotics, you don't just influence or create an impact in in a certain section of engineering. It's not just about humanoid, it's not just about manipulators. You can pick and choose the area you want to create an impact in. And the next one, though it's closely related, it's to the the different fields you can create an impact. This is I think this reason is very personal to me. This is one of the reasons why I chose to enter robotics. That is to improve the safety and dignity of labor. So the first image is fire rescue. We see firemen, we respect them. We are in awe of them all the time because of the dangerous work they do. But the mortality rate of firefighters is 1%. So 1 in 100 people don't go back home. And there's a 20% rate of injury. And the second picture you see is that of manual scavenging. I don't know if the audience of UK would have witnessed this in person, but as someone from India, this is something you see every other day. So these are people who go down manholes to clean human waste, or to clear blocks in human waste and so on. And 6 people die every month in India performing manual scavenging. It's extremely harmful for health, and obviously it has very poor dignity with it. The next one, landmine detection. This can also include any search and rescue operation, people working in nuclear power plants. It is high risk, and we certainly do not want humans anywhere around it, and robots can be used as a replacement for this. And construction work, a very, very common area for employment. The mortality rate in UK, sorry, not in the UK, but around the world is 10%. That is such a high number. So 10 people of every 100 who go for construction work, they don't make it. It is an extremely high risk career. And there is so much opportunity to provide innovative solutions in the area of construction, like painting and high-rise buildings. Even if we increase the safety standards, safety regulations, it's still, there are some jobs which is not very safe, to be performed by human beings. And then there's underwater welding. This might seem to be, a very small section of people working, in underwater welding, but because of the bridges we have, there are many, the reason to do underwater welding arises in much more cases than we think they do. The dangers involved in underwater welding are that of, electric shocks, explosion, hypothermia, and there are many, many more jobs that people do because, they don't have any other go, or maybe they are passionate about doing that, but they should absolutely not be required to do them. And I feel robotics is the only answer, or rather technology is the only answer to improving the safety and the standard of living of human beings. So the reason I'm spending quite some time on this slide is that when I was presented with a number of options after my high school, I picked robotics only because I thought, the others, maybe, if you study business, and so you can definitely create an impact, but these are areas that need imminent attention. So, as a lot of speakers mentioned before, there are diverse work opportunities available once you study robotics. So it's not, some people think that people who study robotics just become engineers. While most of them start off as engineers, they don't need to work as engineers as such. You can become an executive, you can manage a team of engineers if that's what you want. You can become an academic, that's get into teaching, get into research. Or you can even become an entrepreneur. I think there's a lot of demand for small scale robotic applications to be made. You can target a group of customers, and you can definitely become an entrepreneur if that's if you're interested in business, and you also think you have capabilities, skills that would benefit engineering. You can always become an engineer and do a little bit of research and then move on to set up your own business. That is also something you can do, and it's very common people do that even when they get a PhD or so. And then I think maybe 20 years ago, 30 years ago, there might have been lesser representation of women in engineering or research, high-level research. But the doctoral program that I'm in, it's called AgriForwards. The Center of Total Training AgriForwards has almost an equal gender ratio in agri-food robotics research, which I think is something we definitely have to appreciate. We have students across age groups. We have some very mature students as well as, and also we have beginners. And then we have students from different countries, all races, and everybody works in a very, it's a fun work environment, to be honest. And robotics is one area where your appearance or your capabilities, nothing matters. It's only your work that matters. It's only what you do that matters. So finally, I think, as Isabel mentioned before, a lot of people stop from choosing an engineering degree or choosing robotics because they think they're not smart enough. But you don't actually need to be very smart to study robotics. I like this quote by Albert Einstein. It says, "It's not that I'm so smart, I just stay with problems longer." And over the years, I've realized that is very true. Intelligence can take you so far, but you have to persist when you hit upon a roadblock. You have to work hard. And as with any other career, engineering, it gets better with time. You get better at what you do with time. So even if you think you're just average at mathematics or coding, but you have an interest, you have an inclination to contribute or pursue research, you can give it a go. It's not a room filled with genius people, because I know I'm definitely not one. So I would say you're smarter than you think you are. And finally, I'd like to conclude. This is today, I think, is the International Day of Women in Engineering. I have asked myself what I think is the most defining feature of my identity, because we talk a lot about, about being a proud woman in engineering and so, but when I thought what the most defining feature of my identity was, I think it wasn't my name, not my gender, not my race, and not even my beliefs. I think the most defining feature of my identity is action. It's what you do that matters the most. And saying that, I wish all the listeners nothing but the very best. Thank you.
Thank you, Rupika. I'm sure you have inspired many of our listeners to think about a career in robotics. It's such an important field to be in right now. So thank you very much. And that quality of persistence that you mentioned, absolutely critical in so many professions, but especially in engineering, I think. And that final comment about action being your defining feature. Yes, absolutely brilliant. Thank you very much, Rupika. And thank you to all the speakers. I'm certainly inspired. Kind of wish I was starting my career at the other end of my career. I'd certainly be thinking about engineering right now. But we're going to move on to the section. We've seen already some lovely questions coming through, and I'd like to be able to share them with the panel. So if we could have the other panelists on the screen, please. Wonderful. Everybody's coming back. So we can all have a go at some of these questions. That would be brilliant. So let's have a look. Here's a really good one to start with. It's from Eve Whitworth. Thank you for being with us, Eve. Fabulous that we've got an audience asking great questions at the moment. Have you ever, at any point in your journey, been deterred from pursuing an engineering career based on your gender? And if so, how did you deal with it? I guess, Minnie, you've had the biggest, or Isabel, you've had the longest run at your career so far. Have you had any of these experiences?
Maybe I can take my turn. Thanks for the question. In my experience, I never had any such blows. So it was a smooth journey. I'm really grateful, I didn't have to face any such challenges. So my answer is very simple and straightforward. It was an easy journey for me. Thank you.
Brilliant. Has anyone, Isabel, have you ever faced any prejudice because of your gender?
I would say no, not during my studies. Absolutely not. I might have feared some of that, but then the reality was that I was just one more of the guys, if you can say it that way. My experience has been that it's very easy to work with men along with women. There are certain differences in styles, but it's very, very good. I think that many times the issues arise in your own minds. As I think Sami was saying, when you enter a room and you are quite young and everyone in the room are older men, more experienced, and you find yourself having to stand tall and talk the talk and be credible. Yes, there were some moments, but I just had to feel strong, believe in myself, know my stuff, and be confident, or pretend to be confident sometimes, but also be truthful. When I didn't know, I'll say, listen, I don't know the details, but I'll look it up for you.
Thank you. And it is so often the case that we might feel insecure in a particular situation. But that's really good advice, Isabel. Shami, Rupika, or Imogen, have you had any of these experiences along your journeys?
I haven't. I have never felt any discrimination, I'm happy to say.
That's brilliant. So no barriers put up. Yeah, Rupika.
I think that, like as you said, there's no discrimination as such, but sometimes, very rarely, this is talking about 1 in 1,000 cases, you might be laughed at sometimes, because your opinions might be considered to be sillier than that of a man's. Yes, it is there, but I think if the person asking the question has indeed experienced it or is scared of experiencing it, you just laugh and move on. It's absolutely not a big deal. So
it's their problem, not yours, I think you're saying. And I'm really pleased, Rupika, that you told us that on your robotics program, it's equal men and women studying. So I just think that's fabulous. It's really great. We've got another question then from Fadrin. Thank you, Fadrin, for your kind words. We have had a fantastic session. It's really good. So yes, advice to young women who are currently making choices about their future studies and considering robotics. So I guess that's over to Minnie and then Rupika to give us an insight into that one.
Yes, my advice will be, first of all, you need to know what you want to be in a few years' time, and whatever you pick, you should be passionate about that. So that's the main thing. So unless you love what you do, there is no way you can excel. And if you are considering engineering profession, obviously robotics is an area that you could specialize, and believe me, there will be plenty of opportunities. So you wouldn't be struggling to find a job if you specialize in robotics. And I would really encourage you to consider that. And within robotics, there are so many different pathways, which are very well paid positions. So there is a big future if you're considering engineering and specializing in robotics. Thank you.
And a growing future. Yeah, Rupika, do you have anything to add?
Yes. I think my views are slightly different from Minnie's. Like, I don't think a person needs to have an absolute idea of what they're going to do, say 5 years down the line or so, because I did not. I only take it by the day. And my advice to those young women are, if you are interested, it's worth taking the plunge, even if you're not sure, is my advice. So, because it was worthwhile for me, it is worthwhile for me. And I think eventually with the coming opportunities, don't let go of opportunities, take them up and have fun. Things will work out.
Brilliant. And I liked Minnie's comments about the passion there, that if you're passionate about whatever you do in life, it'll help you get further along that road, won't it? It drives you. Right, we have another question here from Ebony. Ebony, very good question. Going from A-levels to university or whatever preceded university, how did you find the practical or lab aspect of engineering at that next stage? I don't know, Imogen, would you like to comment on that?
Yeah, I definitely can do. For me personally, I like the practical side, and it's really exciting because you go from a school where you're doing your A-levels where the facilities will probably be so-so to specialist facilities that the academics use for their research you can also use for practicals. I guess the second point that's probably good to flag, you get really long summer holidays at uni, right? So make the most of it and have a placement in industry. So not only do you use the facilities that the academics might use as a test space, but see it in real life, I think is an amazing opportunity. And, Lincoln, for instance, has really good links with Siemens and others. So.
Thank you. Minnie, you were going to come in there. Sorry.
You don't need to worry about practical side of engineering, although engineering will invariably involve a lot of hands-on projects. But there are people who focus only on coding. Like, if you're really good at programming, you can get away with lab-based work. But as part of the engineering education, I'm afraid you wouldn't have a choice but to be active in your lab-based exercises. So you need to enjoy. That's exactly my point. You need to enjoy what you do. And therefore, if you're considering engineering, you need to be prepared to gain some hands-on experience as well. Thank you.
And if I could add, it can be really, really useful when you have a washing machine that is broken. And then you can, by just doing very few simple things, you can fix it. And you keep telling everyone about it for at least 10 years.
Thank you. Yes, so getting those lab skills is helpful, because I guess it's all about understanding how things work. Presumably, I'm not an engineer. Any other comments about that practical side of things?
I have a comment. I actually did find it difficult when I first started labs, but I think you'll get used to it after a few weeks. So yeah, that's my comment. It's not difficult, obviously. It's just kind of a shock because you're not used to spending all this time in the lab, and there are all these unfamiliar parts you suddenly have to work with. So yeah. So
I don't see any other questions from our audience, so I'm going to throw one in there if that's all right. Is team working important in engineering? And if so, how did you learn about being part of a team and working with others to solve problems? I don't know who wants to come in on that one. Minnie's.
I can just share my response because I need to leave for another talk shortly. So I'll just take this opportunity. So when it comes to team working, again, as part of engineering education, we get the opportunity to do group projects. So that is the first experience of doing something as a team. But obviously, as you grow up and when you start working, whether you're in industry or in academia, you need to be part of a team. So invariably, every day I work with several other colleagues, industry partners, and so forth. So it is really important to be a good team member, someone who can either lead or contribute. And team working is really, really important when it comes to engineering jobs. That's at least my experience. There might be other positions that may not demand such team effort, but still this is something often seen. Thank you. Thank you, everyone. I'm sorry I have to leave now. So good to see you all. Thank you.
Thanks for your contributions, Minnie. It's been great to have you. Bye.
I'll probably take that as well. I'll say that there is a mix of situations. Some roles you can do them perfectly on your own. If you are focusing on coding, that can be done on your own, definitely. But other areas, such, for instance, working in a factory, you have to deal and connect with other colleagues within the factory setup, because your actions will impact on others. So naturally, you have to consult with them. Also, the engineering function is transversal across all processes. I would say almost all processes in the factory, from provisions to logistics. So you really need to be a team member so that you can talk with your colleagues and transmit the information that allows the process to just flow seamlessly and without interruptions. And that comes with practice as well. You might be a little bit more shy, but as you find your feet, your ground, you gain your confidence and you start seeing how others work in teams, what works for you, what doesn't work. And it eventually you'll be great at it.
Thank you.
Yeah, maybe if I can add to that, if that's okay, Libby. I think
Yes.
that's like a really good question, because I think there's one kind of topic that we often forget when it comes to engineering. There's like a whole toolbox of skills that probably a lot of people on the call have that they don't associate with engineering. So it's not just like a technician in a workshop with spanners, and it's not just a really brainy person sitting behind a computer doing loads of coding. That actually, like, unless you have the fundamentals like teamwork, if you work in an international team, you know, or solving complex problems or on projects, you need to be able to communicate really effectively, like written, verbally. Also managing time on complex projects where you've got a lot of kind of parallel work streams. And I think those skills people will already have and are really important, and is worth just kind of shouting out to, I think. Yeah.
That's really helpful. So the whole toolbox of being an engineer is so much more diverse, and I think we've learned that today. The other one that Isabel mentioned is creativity, and I wondered if you'd all like to comment on whether you were ever taught to be creative, or that just comes with the territory. How do you end up being a really good creative engineer? Because that's something I hadn't thought about before, perhaps. Rupika.
I think if we are passionate about something, we're interested in finding a solution to something. I don't think creative people are a type. They get creative when the situation demands. So if you're trying to find a solution to, optimize autonomous robots, you start getting creative there. Once you think of the logical options and they don't seem suitable, then you start thinking a little outside the box. You start, looking for inspiration, and then once suddenly something strikes you. So I have interests in things like, say, poetry or music, and I think it's not very different. It's not one type of people who are creative and another type who are not. If something inspires you, you get creative. That's what I feel.
Great answer. Thank you. Anyone else want to come in on that? We're nearly out of time.
I'll just say that there's so much out there. There's so much information. There's so much new solutions that by just looking at the amazing things that are always evolving, always innovations on the horizon, you just feel really in awe of the creativity that's out there. And when we have to find a solution and our usual kit doesn't give you the answer, then is when you have to look outside and find those solutions, or imagine, how would I do this in a different way? And there's the creativity. You're being creative, and it flows.
That's brilliant. Thank you. We're absolutely nearly out of time, and I don't see any more questions from our audience. So would you each be able to give me in one sentence some advice to people listening today who are considering an engineering career, might be a little bit nervous about it? What would your one sentence pitch be to them? I don't know who wants to kick off with that.
I can start if you want. I would just say, never be afraid to say you don't know. See it as an opportunity to learn.
Thank you. That's really, really helpful. Yes, we should all get better at that. I agree. Isabel?
I would say always look for the silver lining. Every loss of success is a learning opportunity. So take the learning and move on from that and build on that.
That's because that reminds us that failure is part of progressing, isn't it? Not everything you do works to start with, and you have to learn and move on. Absolutely. Shami, do you have that one nugget of advice from your experience?
Yeah, mine is kind of very similar to what Imogen said. So my advice would be, don't be afraid to ask questions. Even if you think it's really stupid, just ask it. You might learn something. And maybe your question isn't really as stupid as you think it is.
They very rarely are. Yeah. So thanks, Sammy. Yeah. Andrew Pika.
I would say just do your best. Things have a way of working out.
They do. If you take those opportunities when you see them, absolutely.
Definitely, yes.
Yeah. Okay. Well, thank you to our panel today. You've inspired me. I hope you've inspired. I'm sure you'll have inspired our audience today, and I expect you'll inspire many more people, because I hope lots more people will watch this online. We're going to make it available. So, thank you very much to our audience for listening in, asking those great questions, and being with us today. And thank you to my colleagues who made this happen. Bye-bye for now.